Hey folks, welcome back to More Than a Refresh, the T3D sessions. This is another Postgres Pet Peeves. Today we have Jonah Harris, who was employee number 9 at a former customer of mine, Enterprise DB. Enterprise DB has gone on to be a poster child for what not to do with private equity, but hey, Jonah has since moved on and is doing big and bad and greater things. Jonah, we've known each other for decades. What is your Postgres pet peeve?
Well, I'm gonna have to go back to the very early days, like even around the time you and I first met on the Postgres lists. And I'm gonna say that Postgres MVCC is a big pet peeve. Now, most people just think of vacuum and they're like, vacuum sucks. But as an internals guy, the MVCC just gets me because that's the reason for all of it.
Okay, so for those that don't know, MVCC is essentially what allows Postgres to be multi-user, multi-version, so that as a general rule, writes never block reads and those types of things. Jonah, what about MVCC outside of vacuum? Because we can absolutely bash on vacuum all day long, and people have heard it. And to be fair, vacuum is better now than it was, auto vacuum and all that, even though it's still a bad solution. It's a better bad solution.
Mhm.
What is your main peeve here?
So my contention is that vacuum should not exist at all today, because if you look at the way the Postgres Storage Manager was originally created and the reason for it, which was that Postgres actually supported time travel, and you could actually do point-in-time queries where each of the rows that was stored also had a time min and time max component, just like we have X min and X max for transactions. There was a time component as well, and that used to be stored in two old tables, PG time and PG log. They got rid of PG time altogether around, I think
Right.
it's like Postgres 6.3 when they got rid of time travel, and PG log became PG commit log.
Right.
But the whole reason why Postgres's multi-version timestamp ordered algorithm is there was to support time travel. And then when they got rid of it, they just pulled out the two pieces that supported it, but kept everything else. And they've done it to this day where everybody pays the price for the original design, getting no benefit.
Now, for those who are not database geeks, when we're talking about time travel or point in time, what we're talking about is the ability to actually say, in the future, I actually want to see this data from the past, which some databases now will support like uncommitted read, where there's data on the disk or in the buffer cache, where you can say, "Hey, what's out there that might be there in the future?" But we have the ability to say, "Hey, what's we're at here. We're at milepost 90. I need to see what was at milepost 87, even though that was a month ago or whatever it was." And Jonah's right. We still pay the price for that interesting feature. And if I recall, it wasn't that long ago. This is all relative because I'm old and Jonah's getting there. Um, that we actually ripped out the code itself. It wasn't that long ago. I mean, for a long time, the actual time travel code was still in there. It was just essentially disabled.
Well, I think the time travel I think it was removed in Postgres 6.3, so it was quite a while back. But
I
yeah,
I might be off on this. I'm remembering a conversation with
there were
Tom.
still remnants of it
Yeah,
around,
where
and
Tom was
that's
like, "Finally ripped this last piece out," kind of thing,
yeah, yeah.
you
And
know?
I think the interesting part, as you were saying, with that temporal query, point in time type query feature, is that Postgres was really one of the first ones to have it. And then many years later, and I know you fondly called me the Oracle shill of the Postgres community, Oracle added
You are
flashback
Oracle
query.
still. You
Oracle added flashback query, and everybody made a big deal of how you can do these queries on, oh, what was this value on so and so date? And it's like Postgres had that a long time ago. Then they just ripped it out.
Yeah, and we should make it just as a quick note, although a lot of people don't use it. We still have point in time recovery.
Yes,
So
recovery.
it is possible to bring, if you're set up correctly,
Mhm,
Postgres forward to a specific point of time that may be in the
mhm.
past.
Yes.
But that's a recovery scenario that's usually reserved for CEOs that think they should still be running queries directly against the database, and they blow apart things that you got to fix.
That is a
Um,
separate pet peeve.
yes, that is a separate pet peeve. Now, but outside of the antiquated, right? We can
Mhm.
agree that but sometimes you got to take that. If it ain't broke, it don't fix it,
Yeah.
right? But what's broke here?
So
What's
let's
the
talk
actual
about
peeve?
that. So the real pet peeve is that when I was at Enterprise DB, we were trying to run TPC benchmarks. We originally wanted to run TPCC, and there's just no way in the blazes of hell it was going to happen.
Right.
And one of the biggest problems was the storage manager and how it works. And so I had prototyped at the time back with Simon a
Simon, hold on. That's Simon Riggs, who was the founder of Second Quadrant. He passed a couple of years ago. I got it. You know what, though? He passed doing what he loved,
Mhm.
which was he was learning to fly and he was doing some maneuver in a small plane. And unfortunately, mistakes happen and he is no longer with us. But he was a brilliant
Yeah.
man, someone who I respected deeply, and also a brilliant adversary. So
Mhm.
hats
Yeah.
off to him.
Amazing guy. Amazing guy. But he and I looked at the landscape of other databases, which all used update in place. And so the problem with Postgres is it stores every version of a record over and over and over again, right? Which is what vacuum cleans up. No other database does that. Uh,
Well, hold on. And a key point here, every version from concurrency. So if you've
mhm,
got 1,000 users working on, say, a sessions table, right? Or I should say 1,000 connections or
right.
sessions, not necessarily users. You're going to end up with multiple versions of whatever's being modified, many of them.
Right. Every version that's being modified is basically just a mark the old one is likely no good anymore, and people will follow a chain to the latest one that matches their transaction like horizon. And no other database puts all of that in the heap because it really pollutes the database. And realistically, rollbacks are very rare, and so most every other database is optimized for commit. And I would joke that Postgres's MVCC is rollback optimized.
It
uh,
is.
and
It is.
yeah, and so what Simon and I did, talking to even our boy Jan here, was that we came up with an approach where we would create a shadow relation. Anytime you created a table, we would create a basically an undo relation where anytime there was an update, it would update the main relation blocks to keep the most recent data in the main relation, and then just backward chain into the old relation. So you would still, to some degree, need vacuum, but it would always operate on the data that didn't matter anymore
Right.
on the undo relation. And so then all your indexes and everything pointed to your valid data. And so secondary index lookups were much faster, and everything was, you know, basically as close as Postgres could get without being completely rewritten to operate in the same way that most other databases do.
Now I can imagine the joy, the exhilaration, the jubilation that the hackers list produced when you provided this very simple, logical, real world solution to what people are using Postgres for. What was that response, Jonah? Tell me they supported you and lifted you up like they are great leaders and provided you with a path forward that allowed you to get this committed,
So if we talk about the birth of hot or heap only tuples,
which
uh,
are awesome.
this was the alternative implementation because the community very often does not want to introduce complexity into Postgres. I do understand, especially in those days, that the number of professional database engineers in the community was far lower.
Yes.
So the ability to support complexity in Postgres was much different than it is today. But there was definitely a view that it was too complicated to do it that way. And the easier approach then was to just add heap only tuples, where we would try our best to only, if there's space in the block, put the new versions in the same block, so that you could still generally use normal Postgres like scanning behavior, while getting some of the benefits. The only
But also
problem. Oh yeah, go ahead.
with hot, it had to the what was being or and I believe this is still the case. What was being updated need to not be indexed.
Correct, which is a big problem.
Yes, it's a
And
huge
so
problem.
it only works in a very small subset of cases, which was one of my complaints. And the other problem is it required you to basically bloat your tables to keep that additional data around. So every block ended up having like a instead of having space allocated for updates that would just add a little bit more data, you basically had to allocate n number of additional rows to every block, because that's how it stabilizes over time. So that you end up with blocks that just have free space in them in case there's an update.
Okay, so we got to wrap up here, but let's give me 30 seconds on the nominal solution, practical solution to this problem as a whole.
Practical solution to this problem is update in place. Don't store actual transaction IDs on every tuple. Transaction IDs should be stored at a block level, which then, rather than having 64 bits used all, or well, 32, but will eventually be 64
Yeah,
used all over the place.
we're still living in 2002 there.
You actually store it once at the block level, and then you only have to manage what is your old versions by that transaction ID for a very small period of time, which reduces bloat completely, and is far more efficient because all your updates and everything are on the same blocks. Your indexes continue to work. You don't have all these corner cases.
All right, folks, this has been another T3D Sessions Postgres Pet Peeves, not thieves, peeves, with Jonah Harris, employee number 9 of former client Enterprise DB.